Okay, this is how I would solve this question on a TI-84 calculator. The rate at which rainwater flows into a drain pipe is modeled by the function r of t, where r of t is 20 blah 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 cubic feet per hour. T is measured in hours, and the interval is from 0 to 8. The pipe is partially blocked, allowing water to drain out of the other end of the pipe at a rate modeled by d of t, cubic feet per hour. There are 30 cubic feet of water in the pipe at t equals 0. So I'm going to go ahead and write that down so that I know that I have an initial condition and be really careful that I don't forget about that initial condition. I highlighted the functions because the first thing I would do on my calculator is define those two functions by typing them into my y equals window. So I've done that. And then part A says how many cubic feet of rainwater are in the flow into the pipe during the 8-hour interval. So I'm just going to take the integral from 0 to 8 of the r of t function because I want to know the amount that flowed into the drain pipe. I don't care about the stuff that's going out. On my calculator, I would quit out of this graphing window and I would do math 9 to get to the integral. I'm going from 0 to 8. And I'm going to do that very first equation. So I'm going to do vars, y vars function, and then of x dx. And that gives me the amount that flows into the pipe, 76.570. And that would be measured in gallons because the rate function is measured, cubic feet. I said gallons, but I wasn't paying attention. So it would be a volume amount because the rate function is cubic feet per hour. dt is measured in hours. When we multiply those two together, we get the hours cancel. Okay, and that's all you need to write down for that problem. The College Board knows that you're going to use your calculator. Part B says, is the amount of water in the pipe increasing or decreasing at t equals 3? Give a reason for your answer. Now, this is an example of when I would need an amount function so that I can describe the derivative of the amount function. So the amount function is going to be the integral from 0, which is the 1 point we know, to x of the rate flowing in minus the rate flowing out plus 30 because that's the initial amount. If I take a derivative of that amount equation, well, the first part of the fundamental theorem of calculus says the derivative of the integral undoes itself, so I get r of x minus d of x, and the derivative of 30 would be 0. So that is a function, and now I have the equation for the derivative, and so I can figure out a prime of 3, and I'll show you how to do that on your calculator. So when I'm on this window, I can do vars, y vars function, and there's probably an easier way to get to this, but I don't know what it is, and I'm going to go of 3, and then I'm going to do the same thing for the y2 function. So I'm just subtracting those two values, and it tells me that it's negative 3.14. Oh, 0.314. And so that tells me that the amount is decreasing. And I would say my reason would be because a prime of 3 is less than 0. In calculus, if we have to justify increasing, decreasing, we're going to look at the first derivative. All right, the next question says, at what time is the amount of water in the pipe at a maximum? And what I notice is that this is a a closed interval, and we're looking for an absolute minimum. So this is a really good candidate for the candidates test. And so I'm going to use the candidates test, and I'm going to use the candidates test and the amount function that I wrote in part B. I'm going to look for where is a prime equal to 0, not a prime of 0, I don't care about that, a prime of x equals 0, and that's going to happen when r of x equals d of x. That will be my critical point. So I'm going to go back to my calculator, and even though these functions are graphed, they're not in a good window, so I'm going to fix my window size. I know that they gave me the interval from 0 to 8, and I know that this thing is off the graph, so I'm just going to change it to a 50 and see if that fixes the problem of it being off the graph. Looks pretty good. So I notice that these two cross here, and I'm going to find where they're equal by doing a second calc, and it says intersect. Oops. And it says, do you want the first curve to be this sine curve? Yeah, that's fine. Do I want the second curve to be this cubic curve? Yeah, that's fine. And then it tells me to guess. And the reason it tells you to guess is if there's more than one, they want you to be close to one of them. So they're giving you the right one. So I just made a guess, but make sure you hit enter one more time so that it gives you the actual intersection. So it looks like the actual intersection is 3.272. And so then I'm going to do my table of values. I'm going to use x equals 0, x equals 8, and I'm going to use a of x as my y coordinate. So I'm checking from 0 to x of r of t minus d of t dt plus 30. So I know that if I go from 0 to 0, I would get 30 because that integral would be 0. And then for the other ones, I can use my calculator to figure out what that is. So I can quit out of here. On the 84, there's actually kind of a nice feature that x value that we were on, we could save that value if we wanted to so that we never have to remember it. Oops. I meant to hit alpha A instead of second A. So now that that x coordinate is saved, so I don't have to worry about it. So I'm going to go math, 9. I'm going to go from 0 to A, that value that I saved, of all right. And then I'm not going to forget to add 30 at the end. And I get 27.965. And I would do the same thing for 8. That could save you just a tiny amount of time is if you hit the alpha trace button, those vars options pop right up. So you can get to those right away by typing 1 for y1. It's a little bit faster than the other, than the other method. So that might be an option. Whole thing typed in, so I have 48.544, it looks like. And I can justify my answer by saying by candidates test. The water is at a minimum at t equals 3.272. I paid attention to what they were asking me for. They were asking me for the time, and they were asking for the minimum. The candidates test is probably the best way to do that when you're including the endpoints, so you don't forget to think about those endpoints. Okay, part D, I don't actually need my calculator. Part D says the pipe can hold 50 cubic feet of water before overflowing. For T is greater than 8, water continues to flow into and out of the pipe at the given rates until the pipe begins to overflow. Write but do not solve an equation involving one or more integrals that gives the time W when the pipe will begin to overflow. So this one is also really just making sure that you understand how to find the amount. So from 0 to W of R of T minus D of T dt plus 30, we want to find out when that's equal to 50. And we don't have to do any more than that. Just write that integral out. And the integral is the amount equation again. All right. Thank you so much. Bye.